What I would like to highlight here, it was not from Newtonian or post-Newtonian, but I would say pre-Newtonian physics, right? From the Bharatiya Gyan Parampara, where we see this simultaneous development of the mathematics and the astronomy, so to say, right? And the application that was synchronized, right? It was going hand to hand, it was going together, right? And till we appreciate that, we cannot understand the enormity of this, right? And that's why I started with this whole contextualization that Einstein's relativity would have been nowhere if differential geometry was not advanced as it was, right? Because everything from the Ricci tensor to the curvature aspect, right, to how we define the stress tensors and the transformations thereof, right, covariance, contravariance, so on and so forth, right, translation in certain manifolds. These are all things that came from differential geometry that translated into Einstein's relativity, general relativity. So similarly, because of Aryabhatta's work, because of Brahmagupta's work, because of Bhaskara II's work, and their synchronized corrections in astronomy, their applications, we would not have reached where we were.
Namaste viewers, welcome to Sangam Talks once again, and we are on the third episode of our series, that is the physics, the subject of physics from the lens of IKS, Indian Knowledge System. So in this episode we will talk about optics, that is the subject of light, and not only light, also we will touch upon gravity and gravitational waves maybe, right sir? And let me welcome Dr. Mrittunjoy Guha Majumdar once again, sir. Thank you very much. So for centuries humanity has been unraveling the mysteries of gravity and light. Gravity, an ever-present force, remains an inseparable aspect of our existence, while light serves as the fundamental tool for the observation in tune with the empirical nature of physics. Our journey has taken us from understanding light as both a particle and a wave to the groundbreaking discovery of fermions like tachyons, which is maybe faster than light. So we never know. We are still discovering things. Each step marking a significant evolution in our comprehension of the universe. So sir, let's start with the question of light. Light exhibits both a wave-like property and a particle-like property, a duality central to quantum mechanics and relativity. How do ancient Indian theories of light offer alternative perspective of on the fundamental nature of light and its interaction with matter?
The study of light is a very important aspect of the advent of modern physics. Before the 20th century, light was seen as primarily relating to the wave-like tendencies in nature itself. Back in the 17th and 18th century, we had prominent physicists like Huygens, Euler, even Hooke had worked on this. And there is a very well-known experiment called the Young's double slit experiment, which we had discussed when we were discussing quantum mechanics. When just around the 20th century, the turn of the 20th century, Einstein came forward with this understanding of the photoelectric effect. And the photoelectric effect was a very seminal, a very important kind of milestone when it came to physics itself, because it told us that light, when it is impinging, it is hitting a metallic surface, it doesn't quite lead to any prominent kind of emission of electrons from the metallic surface till it has crossed a certain frequency. The light itself has a certain frequency. If we had thought of light as a wave, then the intensity of the light, if it is increased, it should have led to the emission of the electron given the higher intensity, so to say, which is not what we see basically. The fact that it is frequency dependent and not intensity dependent first brought forth this idea that the light itself is coming in packets of energy, right? This idea of quantum essentially. So in 1877, roughly, Ludwig Boltzmann, the very well-known physicist, he had mentioned that energy states can be discrete. right? And in 1900, Max Planck said that what we see in nature, whatever radiation we see, is basically because of radiations from oscillators, right? Oscillators are systems that oscillate, essentially, as the word suggests, and they give rise to discrete energy levels, right?
Creating waves.
Creating well, the wave packets, right? Packets of energy, so to say. And Einstein, what he did, he went one step further. He said, it is not the body itself which has oscillators, but light itself is composed of packets of energy, right? So this was a very interesting thought, but it was much later that we understood that wave and particle, right, not only for light, but even for matter, it is part of a duality, right? Everything which is a wave is also particle in its own way, and particle is also a wave, right? So when the Young's double slit experiment was done with electrons, right, Hitachi recently did an experiment where they fired 1,60,000 electrons through a double slit experiment, and that reconstructed the Young's double slit experiment with light, right? So it was very interesting. That means that electrons also have a wave-like tendency, essentially, right? Now, when we talk about Bharatiya Gyan Parampara, one of the prominent schools of thought which we have discussed in the recent past is that of Nyaya Vaisheshik. And in Nyaya Vaisheshik, this the concept of Tejas as a dravya has its own constituent, particles, parmanus, essentially, and the gati, which is the motion that is associated with it, right? So it has a certain aspect of quantization, if you will, right, where the Tejas is carried forward by a certain kind of particle which is associated with it, essentially, right? So Tejas serves both as basically a source of illumination, right, and a medium or a channel for the interaction to happen, right, or for this Tejas element, right, to be applied in any physical context, so to say, right? Now, one aspect of light which I would like to highlight here is that one of the pramana of Bharatiya Gyan Parampara has been that of pratyaksh. So pratyaksh praman is when you have a certain kind of connection between the sensory object, which is a sensory agency or sensory element like the eye, for instance, and the object that you have out there. So in fact, Nyaya, in the Nyaya school of thought, right, there were a lot of aspects or discussions on how light is very, very important for that to happen, right? Because without light, there is no element of pratyaksha, right? Pratyaksha praman is looked at as actually it cuts across most of the darshan, the Shad darshan. Pratyaksha is definitely there somewhere or the other. The others like Anumana, even like Anupalabdhi, for instance, and so on, they are not quite as prominent as Pratyaksha definitely is, right? So in fact, in the Nyaya Sutra, right, we see that the perception is defined, and I quote, knowledge that arises from the contact of a sense with its object, which is determinate, non-deviating, and non-verbal, right? Determinate, non-deviating, and non-verbal, right? So the Nyaya emphasis on the conditions for visual recognition, right, they kind of remind me of the various conditions in optics as we know it, right? The ways in which light is kind of helping in terms of illumination of objects, let's say, right? And how do we kind of perceive it, how it helps us in terms of understanding things, right? And it relates to waves, it relates to the ray optics also, right? In different regimes, we have wave optics and ray optics and so on and so forth. Now, you may ask that, well, that is at the level of metaphysics, at the level of epistemology, if you will, or the ways of accessing knowledge. What about light in the more direct sense, right? In the sense of application, let's say, right? So even in that, we see that within temple architectures, right, within different kinds of temples across the world that we see, there are various elements of how to manipulate light, right? How to direct light to do illumination either of the chamber, the inner Garbhagriha, for instance, or even to do a Surya Tilak, right? Which is basically the tilak on the deity with help of the Surya, the light from Surya Dev, right? So the thing is, we have seen this in the context of the Sri Ram Janmabhoomi Tirtha Kshetra Mandir, which has been recently constructed and is open now. after a long battle, I would say, of over hundreds of years. So the idea is that this Surya Tilak, the concept of Surya Tilak, has been there from quite some time actually, right? So for instance, the Suryanar Kovil temple in Tamil Nadu, the Koba Jain temple in Gujarat, the Balaji Surya temple in Madhya Pradesh, the Gavi Gangadhareshwar temple of Karnataka, right? They all have elements of the Surya Tilak, right? In some of the cases, it's more natural formations. I mean, like for instance, in a cave, right? How it is redirected, it's not quite constructed in that sense. But in other cases, even in the Konark temple, there are various elements which relate to Surya Dev, right? And the element of light and aspects of the sun, essentially. Yeah.
Surviving temples of North India.
Absolutely, and they connect the illumination aspect, right, and how to use your agency in terms of optical elements, if you will, mirrors mostly, or shining kind of elements to redirect the light in specific ways. Now, going back to this idea of wave particle, which I started with, one may ask whether wave particle duality has been mentioned in the Indian knowledge systems, right? So not quite in the context of duality itself, but the non-dualism that is inherent in Advaita Vedanta or in Prakasha Darshan, for instance, does talk about various complementary or even very, very contrasting perspectives or tendencies being reconciled in a one underlying substratum, right? So if you talk about the wave and the particle-like nature, one of the first things that students in quantum physics ask is basically, how is that possible, right? Because what we see around us is definitely not a wave at times, right? We are not waves. We don't have the waviness in us, which is visible, right? So what do you even mean by saying that a particle is a wave and a wave is a particle, right? So the good thing is, and I often discuss about this, is the Planck's constant, right, is the way it is. Because if the Planck's constant was not as small as it is, then maybe the mediation of the wave particle nature would have been much more obvious, much more out there, right? There could have been various interesting aspects of this duality, so to say, right? So that aspect is reconciled. These very different perspectives on the same thing, light, let's say, or matter, right, is so contrasting that it cannot be, it is almost like opposites. Right. So in my Trika Shaiva Darshan talk, I had mentioned about Abhinav Gupta and how he spoke about the interplay of opposites. In the Nasadya Sukta, right, we talk about that which neither exists nor non-exists. So we are talking about that layer of reality where things, even the binaries, even the opposites, are being subsumed, are being dissolved essentially, and they are part or constituting the same reality, so to say. Now that is happening at the level of the spiritual realm. That has been in a way resonant, in a resonant manner, seen in the context of this duality, and in fact this duality has been further qualified now to a triality. So wave particle entanglement triality. This is the latest development of sorts, one of the recent developments, where we are talking about how the systems, the particles of light or light itself, how it is correlated. That also defines or constrains how the wave and particle duality will be seen in nature as such, right? So this whole dynamics of how the duality comes about is something which is very, very counterintuitive, which is very non-classical, but within the non-dual traditions, at the metaphysical level, at the spiritual level, if you will, transcendental level, we do see various binaries of this kind of where the interplay of opposites are happening, being reconciled within one ontological or one kind of one reality, so to say, one ontological category or a reality, so to say. And that has been seen in various texts, in the Ishvara Pratyabhigna Karika, in even Sri Adi Shankaracharya's texts, when he has written about this in detail in Atma Bodh, for instance, and so on and so forth. So this comes forth in a fairly visible way, so to say.
So like without the Planck constant, it's photon, maybe the virtual photon.
Right. No, I mean the Planck's constant plays a very important role. I mean, because even in the uncertainty principle, when we talk about the simultaneous uncertainties of things, the mediating kind of constant is the Planck's constant, so to say. And when we talk about Planck's scale, right, that is the smallest scale in terms of space-time, if you will, which is very important in quantum gravity and aspects on that front. So it is very curious that why is Planck's constant the way it is, right? Is a question that people ask, right? I mean, but there is no like answer. There are speculative answers, of course. And if one goes with a multiverse theory, then one could say that there are other universes where the Planck's constant may be very different, let's say. And that would lead to very different dynamics, very different kinds of physics, right? I mean, if we go with the wave-particle duality, potentially a particle will start looking like a wave in even the macroscopic sense, right? And that is a very weird thing to think about.
Everything is like physics, it's come again and again, it's the ratio.
Yeah. The ratio, right? I mean, how you kind of define this duality also, if a particle has some momentum, the wavelength is defined by h by p, right? H bar by p, which is again a ratio, right? The Planck's constant divided by the momentum.
Lenz's law.
Right, Lenz's law. There are many aspects, right, where you look at the proportions, right, the ratio, so to say, and that gives rise to certain non-trivial kind of characteristics.
So we now talk about the famous Michelson-Morley experiment. Well, that changes things. So the Michelson-Morley experiment invalidated the classical ether theory, leading to the realization that the speed of light is constant across all reference frames, a key postulate of spatial relativity. Did Indian astronomical traditions such as Aryabhatta's treatment of planetary motion, gati, that motion, and relativistic time effects anticipate aspects of Einstein's space-time transformation?
So the Michelson-Morley experiment was a very path-breaking experiment, because till that point in Western philosophical and scientific traditions, the idea of the ether was very much important, and the idea was of a luminiferous ether, right? Luminiferous ether, which is basically a all-pervading medium through which light also should be moving through, essentially. And the idea was that if we look at the rotation of the Earth and we have light which is passing in the direction of the rotation and perpendicular to the direction of rotation, the drift of the ether should lead to a change in the path of the light taken. Now, in the experiment, this was not seen, which means that there was no luminiferous ether. So this was a way in which the interferometric setup, which they used, Michelson-Morley used, and it's a very famous kind of experiment, showed that luminiferous ether is not something we see in nature. Now, if you ask whether we had the concept of ether, number one, but before that, we should talk about what happened when the concept of ether was removed from the picture, right? Because there's no medium left, and Einstein, taking the example of, or rather the work of Maxwell, right, the work on electromagnetism, and the idea that the speed of light, the velocity of light, is invariant across frames, went ahead with the formulation of special relativity, which basically said, and which basically got rid of the absoluteness of space and time, which Newton, for instance, and many other people, everyone in the world of physics was attesting to till that point. He said that space and time itself is frame dependent. So a person who is moving and a person who is stationary, the way they will measure time or they will measure space is going to be different. So there were many such paradoxes also, right? For instance, there was this paradox of the which is called the twin paradox. So if there are two twins and one of them, with the help of ISRO or NASA, is sent away in a space shuttle and they go to some distant celestial body, turn around, come back, the ages of the person who was on Earth and the twin who had gone away will not be the same, right? That is because the way time passes and how it is measured and so on is not quite the same. Now that's still there are a lot of debates around this paradox and how you resolve it and so on and so forth. But the idea is that there is a frame dependence. There's a context of this frame essentially when you're defining space and time. Now the question is, did the Indian knowledge systems have something of that kind? Now if you ask me about the mathematical aspects, right, Minkowski spaces and the transformations, we don't find evidences of that, of course. It was not mentioned in that way, it was not formulated in that way. However, this aspect of relative motion and how that affects time, how it affects the conceptualization of movements and motion for that matter, definitely is seen. So when we talk about Indian astronomical traditions, in my talk on the Mahakumbh, I had mentioned about how Prakarana, right, this idea of precession, was accounted for in the Indian zodiac, and how that leads to the astronomy and the astrology. I mean, I don't like the word astrology, I like to call it as Ganita Jyotish, right, which is the right thing to call it essentially, because astrology, when we talk about in the modern context, talks about, yeah, it is more of divination and aspects of that front, but Ganita Jyotisha was more to do with mathematical and astronomical concepts. So the zodiac of the Indian systems is much more in line with the astronomical findings than the Western zodiac, so to say, and that is purely because the prakarana, the precession correction, has been done in that sense, right? Now, in our Indian traditions, we have had very advanced techniques of understanding where the corrections have to be put into place. So Aryabhatta, right, when he spoke about his planetary motion, right, he had an heliocentric like model, of course, but the planetary motion was relative to the observer's frame, right? This aspect of gati, the motion essentially, was rooted in an understanding that the earth rotates on its axis, right? There is a rotation of sorts, and which provided an elegant explanation for the apparent motion of the celestial bodies, so to say, right? So this idea, though not directly connected to space-time transformations, right, or time dilation or length contraction, reflects an awareness of relativity of motion, right? I mean, before even Copernicus or Galileo spoke about it, because those of us who are into physics and the transformation, so to say, there is Galilean transformation also, where we do talk about relative motion, but not quite in the Einsteinian case, right? So we are talking about something even before that, right? So there is an aspect of relative motion that we are talking about here, right? So Aryabhatta's work also explores the notion of time, the kal, essentially, right? So he described it as a continuous measurable entity, right? And he emphasized the fundamental role of time in the celestial dynamics, so to say. Now, when we come a little ahead, when we talk about Bhaskara II, Acharya Bhaskara II's work, he basically looked at time cycles and orbital or orbit mechanics, right? The mechanics of different kinds of orbits, so to say. And his idea of variability of time, right, his idea of how planetary equations and non-uniform motion takes place, again shows an advanced understanding of temporality and relativity also to that extent. Again, not in the way that special relativity talks about it, of course, right? So in the last interaction, we spoke about how the different realms of reality, right, leads to different understanding of time scales, right? And this is a very important concept which we were discussing earlier as well about. One very interesting story is that of Bhishma Pitama from the Mahabharata, and how Bhishma Pitama was the child of Ma Ganga, and Shantanu was the king of Hastinapur. And she basically, there was this whole story about, she said that I will sacrifice, she was sacrificing the children, and she said, you don't question me why I'm doing it. And Shantanu did question her for the last child, right, which was Bhishma. Yeah. So and so there is a backstory of that as well, which why that happened in the way it happened. Now, when Bhishma was a child, right, and when he was in a conflict as well, then internal conflict, when he was asked to take the throne at one point, and then he was later after the Mahabharata Yudh, right, or roughly during the Mahabharata Yudh, there were many aspects of when he was lying on that bed of arrows, and Ma Ganga came forth, right? She came forth and even nourished him in a certain way. She gave him wisdom, advice, essentially. The appearance of Ma Ganga, right? You can say that it is because of her Devya, roop, but you can also think of it in a different way, right? As we discussed last time, right? Which is that the time aspect of different realms, right? In a metaphorical sense, of course, it's not in the sense of frame dependence in that way. The blink of an eye for somebody in a certain realm could be an entire lifetime in a different realm altogether, right? So this beautiful way of frame dependence and context of how we define time scales is a very important concept that we do see in the Indian knowledge systems, so to say. So, for instance, Brahmadev's day is 4.32 billion years, right? One day of Brahmadev is 4.32 billion years. So this temporal framework is very important. Now, when we talk about Yuga and Yuga Sandhis are basically the conjunction of the Yugas, right? So when we say the transition from one Yuga to the other, there are many treatises which talk about it, and in the Linga Puran and in the Vishnu Puran also we find mention of this aspect, right? So the way things happen at that conjunction, right, there is a lot of aspect of decay of morality, there's a lot of aspect of how the qualities change in society itself. But there are also some aspects of time and how it passes and what happens in terms of the reorientation of the passage, the transition, so to say, right? And that's a very important and interesting way to think about the aspect of where the epochs, right, the epochs change, right? And this is also interesting in a different context, because in our cosmological models, even there in astronomy we talk about epochs, right, in cosmology and astronomy. So for instance, there was an inflationary epoch, right, inflationary, when the universe was rapidly expanding in a very short period of time, 10 to the power minus 36, I think is what is regarded seconds. In that period it rapidly expanded and then it became whatever it was, and there was a radiation heavy epoch, right, then the matter came about and so on and so forth. Even in that there were fundamental reorientations, right? There were times when forces became divergent. There was one fundamental force, this is a hypothesis of course, and that gave rise to more kinds of forces. So earlier all the forces were one and then they slowly diverged. Similarly the laws, similarly the constants, and even space-time potentially. Of course, this is still not proven. I mean, we cannot go back and test the epochs before, but there are some signs, some things we can kind of, using microwave background radiation and so on and so forth, we can find signatures of what may have happened back in time and so on and so forth, right? So that is very, very important, so to say. Now, the Puran talk about these transitions very interestingly in the sense of subjective time and perceptible time. Right, subjective time and perceptible time, and how the transformations in society are happening in the way they are, right? So again, it's not quite time dilation, right, or the relativistic Minkowski transformation, but it is a certain other way of looking at time itself, right? Now in Surya Siddhanta there are many ways in which the correction of your actual motion of the celestial body and the perceptive or the perceptible kind of motion has been spoken about, right? So there are texts which look at the calculations from a frame dependent perspective, right? And there are those calculations which look at the position and the motion of these particles, or sorry, these celestial bodies, right? And the planetary latitudes and declinations are looked at from a astronomical corrective calculation perspective as well, right? Now there was a point that I raised earlier, which is that of ether, this aspect of ether. A question that comes to the fore is, even in Indian traditions we talk about Akash Tattva, and there is a misconception I just wanted to kind of correct before I kind of move on from there, is that we say that the transformations taking place in the absence of ether in the Western context means that Akash Tattva also should be summarily removed from the picture. That is not true, because the way we define ether is not quite the way the Western philosophies or traditions define ether. So luminiferous ether is something which has a certain mass aspect, massive aspect, a drift element of it, and a resistive aspect, so to say, right? It resists the motion which is of things in it.
Right? Can I call it as the aspect of dark matter?
No, not quite, because dark matter is going into kind of looking at something which has a mass, right? But it also, there are certain other characteristics, right? I mean, you can say it has a resistive component. Even dark matter has a gravitational component which we talk about. In this case, it's a resistive component. It's almost like a viscous component, viscosity, right? And something, when it's moving through it, it is impeded in some ways. Whereas when we talk about ether in the context of the Indian knowledge systems, we are talking about the fundamental first element that comes about, right, when the creation has started in the empirical sense, whose qualifier is sound, right? Sound is its qualifier, and sound, again, I would say, is not quite sound in the way we think of it, right? It's more of the vibratory aspect of things.
Classical sound need a medium.
Right, so it is more vibratory, right? It is more about the fundamental vibrations that exist, right? So I mean, and so when we talk about gunas, when we talk about ether, we have to make that qualification of sorts, right? So this element of how we define the element of relativity, so to say, so when we say Bhaskara's non-uniform time, treatment of non-uniform time, or Surya Siddhant's reference frame dependent adjustments or calculations to correct for astronomical calculations, so to say, or knowing about declinations, many aspects of the planetary motions, celestial body motions, then we definitely see that there is a, what I call as proto-relativism, right? Proto-relativity rather, which prefigures this relativity. but is not quite relativity in the sense of the mathematics that we know it in the Minkowski sense, right? So in that way, definitely, right? I mean, even from a philosophical perspective, relativity, as we will discuss going forward, has played a very important role in Indian knowledge systems, right? From the Jain Parampara, for instance, in Advaita as well, in Sankhya, even in Buddhism, we talk about many aspects of dependent origination, right? There's Pratitya Samutpada, which is basically dependent origination, so to say. So, yeah.
So you already explained, touched through the subject like special relativity and introduced time dilation and length contraction, fundamentally alternating classical notion of space and time. So how do Indian philosophical concepts of Kala in Vedanta, Apekshikatva in Jain epistemology and cyclical cosmology in Hindu thought align with or challenge these modern relativistic insights?
Right. So when we talk about time dilation and length contraction, we have to understand that that is the most kind of one of the most fascinating thought experiments, or you can say formulations of Einstein. There are, for instance, many interesting examples where you have let's say a certain kind of object, right? Let's say a beam, and in one frame of reference the beam is looking as if it is longer than a tunnel. Let's say it's on a train, this object, and it's moving across into a tunnel. And what I have is that at any point in time, one of the doors of the tunnel, let's say there are the doors on the tunnel, one of the doors is shut and the other is open, right? So when it is coming in, I'll shut the door. As soon as it is inside completely, I'll close the second door and open the first door. Now it was seen that in some of the frames, this thing is perfectly fine when we are in the frame of reference of being on the ground, when we are stationary. Okay, so there we construct it such that the object is exactly the same length as the tunnel, right? But if we go on to the train, if we are standing on the train, right, then the way in which this idea of simultaneity, right, when this closes and this opens, it faces a paradox. And what is the paradox? The paradox is that the length of the bar, the beam, seems to be longer than the length of the tunnel. So how do you reconcile that? Because if the beam moves into the tunnel, how can you close the second one and open this first one together simultaneously? Because it will have to move in completely, and then if it is larger than the tunnel itself, right, it will have to move in further before you can close this and open this as such, right? And you'll have to open this first itself, right? You'll have to actually have a certain point in time when both are open, right, if it is longer than the tunnel itself. So these paradoxes come from this aspect of length contraction and time dilation, right? This aspect that when you measure lengths and when you measure time, it depends on which frame you are measuring it from. If a person is moving and if it is stationary, they are different, right? So this aspect in the Bharatiya Gyan Parampara, when we talk about Advaita Vedanta, we say that there is an aspect of Paramarthika and Vyavarika Satya. We have spoken about this previously as well, and Kal itself is something which is seen as emergent, and it is something which is in the Vyavarika Satya realm, right? For Paramarthika Satya, this element of Maya comes in, and we say that it is not, I mean, the fundamental reality is not dependent on time, right? Time emerges from it, right? So it is not something which is independent or which is absolute in that sense, right? Now in Jain epistemology, there is a very interesting formulation, which is what you mentioned, Apekshikatva, right, which is basically relativity. And that is part of the Anikantavad doctrine, right, this aspect of the larger multifacetedness of reality, right, Anekanta, right, Anekantavad, basically multiple ways in which you can look at reality. And I think in one of the talks I mentioned about how the elephant parable is present, right? So Jain thinkers said that reality is fundamentally multifaceted, right? And there is a frame dependence or an observer dependence, you can call it. And that also connects to this aspect of Syadavad. Syadavad is basically that any statement is only conditionally true, right? It is only conditionally true. And in fact, the Jain epistemology is very interesting, that we talk about the Chatushkoti, right, which is basically the four doctrines, the four logical kind of statements, right? I mean, proposition, negation, conjunction, and double negation. In Syadavad or in Jain epistemology, you talk about the 7-sided logical construction, right? There are 7 actually in that, right? So it is a much more kind of multifaceted way where there is a qualifier also that is put in some of the statements, and that makes it go from 4 to 7 essentially, right? So in that sense, Jain epistemology gives a lot of interesting insights, right? Both from the aspect of Anikantavad, right? From the aspect of Apekshikatva, right? And as well as from the aspect of Syadavad in that sense, right? So the idea of frame dependence, even from the conceptual realm, right? You have to qualify something, it is contingent on some clauses, right? That is very, very important. Now we spoke about the Surya Siddhanta previously, and there is something known as Drik Siddhanta and something known as Shuddha Siddhanta, right? Drik Siddhanta is basically when you talk about the apparent position or the positioning of a celestial body, and the Shuddha Siddhanta is when you are talking about the actual, the real, true kind of aspect of reality itself, wherever the body actually is, right? Now there were a lot of different calculations or commentaries you can call it, or ways in which these observational factors, right? Like one very important factor in optics, which we all know about, is parallax, right? Parallax, how we account for parallax when we are looking at a distant object, right? There is what should have been in some place looks to be somewhere else, right? How do you account for that correction, right? So in Surya Siddhanta, when you're talking about the Drik Siddhanta and Shuddha Siddhanta, inherently the parallactic aspect obviously as well comes in, right? And there are many ways in which the calculations of Panchang, when we talk about, again it comes back to this aspect of Prakarana, that is another side of motion that we have to account for. So the sophistication of corrective measures for astronomical studies in the Indian traditions is so very advanced, right? It is so very kind of multifaceted in its own way, and that also relates to this aspect of relativistic aspect, so to say, right? I mean, how do you look at relative motion of somebody who's on Earth and a distant kind of celestial object for that matter, right? And when again we go back to this aspect of linear progression of time, right? When we say that Hindus had a linear progression of time, we didn't quite. We had a cyclical model, so to say, and that itself showed in some ways the non-absoluteness of the entire construction of space-time, going back to the Advaitin aspect. And naturally, if something is emergent, it always has to be contextual, right? It always is context dependent, it always is frame dependent. So from a metaphysical aspect also, I would say we always looked at that aspect very, very closely, essentially.
So our ancestors understand frame.
Well, frame, but I mean the transformations, if you say the mathematics of it, I mean, being a scientist and a person from science, I wouldn't go so far as to say that we had the transformations till I find the treatises that did so, right? But in the sense of very specific astronomical treatises and traditions, corrective aspects were definitely present, which showed an understanding of relative motion as well.
So talking about astronomy, ancient Indian astronomy, we have the great matrons like Bodhayan, Aryabhatta. So Bodhayana's theorem is there, Bodhayana's theorem which predates the Pythagorean theorem actually. And later works by Aryabhatta, Brahmagupta and Bhaskara too. The mathematical foundation for celestial mechanics. How did Aryabhatta's work on pi, Brahmagupta's use of zero and negative numbers, and Bhaskara too's early concept of calculus contribute to the mathematical framework needed for understanding planetary orbits and space-time curvature?
So mathematics is a very, very integral part of physics, right? It is the language of physics. And in fact, recently I was discussing with some of my students about this very beautiful thing called cymatics. Cymatics, I think we had briefly discussed it in a different context once. So cymatics is when you have geometrical patterns formed because of music, right? Because of sound essentially. And this is what we call as geometry heard, right? There's a philosopher who called it music as geometry heard, right? Now, it relates a very fundamental aspect of reality itself, which in our traditions we talk about Shabda Brahman, of sound as fundamental, and how mathematics is integral to that, right? Geometry is connected to sound is something we see in for instance, even Hooke, who is very well known for his work on cellular mechanics, right? The biological aspect of cells and so on. He even talked about how the different kinds of vibrations can lead to different non-trivial geometric patterns, right? So why am I talking of this? Because mathematics almost presupposes or premises different ideas of physics, of reality itself, right, from both a Bharatiya Gyan Parampara perspective as well as from modern science. I always say that when general relativity came about, the mathematics of that, which is differential geometry essentially, was quite advanced in the previous 50 years. Okay, so from around 1850s onwards, Larmor and various others, there was a lot of progress in the mathematics of that period. And even on the side of special relativity, when we talk about quantum aspects on the quantum physics side as well, many of the building blocks, right? I mean, in the case of general relativity and special relativity, it's the math, the of transformations, right? Minkowski transformations and differential geometry for that matter. In the case of quantum mechanics, we talk about packets, wave packets, and how discrete states can exist. I often say that there was a lot of groundwork already established in the previous 50 years. What Einstein did differently, right, was he took a plunge, right? He took a plunge of faith, if you will, but if it was more of a scientific plunge, and he took the idea forward, saying that this is actually a very good language, right, to talk about gravity. This differential geometry actually talks about gravity in a certain context. And there is a reason, I mean, there's a whole physical reason how he got to that point. But he said that gravity is no longer something which is a force, right? Gravity is something which is more of a curvature in space and time, right? So if you can think of space-time as a tarpaulin sheet, as it is often mentioned, and you put a small marble ball on it, the curvature that happens is basically the effect of gravity. Because if you now put a small, let's say, lead bearing, there is a smaller ball, let's say metallic ball, and you pass it, let it roll on the tarpaulin sheet, as soon as it goes near that curvature, it will kind of move around it, it will circle it almost, right? So you can think of curvature and gravity from that perspective. So clearly the mathematics presupposed the physics of it. So in the Bharatiya Gyan Parampara, we also see a resonance of that kind, right? You just now mentioned Bodhayan, right? I mean, we should actually stop calling it the Pythagoras theorem, right? We should start calling it the Bodhayan theorem, right? And the work of Indian mathematicians for determining pi is very, very important, right? So for instance, in the Shatpat Brahman, we find the first mention of a way to talk about pi with the value often cited as 3.139. Aryabhatta, he kind of gave this value at 3.1416. Madhava of Sangama grammar later on gave a value up to 11 decimal places, right? He said 3.141, 592, 653, 59, right? So that level of precision, right? And because pi is very important for any kind of circular dynamics, circular aspects, right? And invariably, if we talk about orbits, if we talk about the way things are rotating or revolving, there was a lot of translation of that into talking about planetary motion as well, these understandings, so to say, right? And when we talk about the treatment of planetary revolution, the way they looked at the circular mechanics, of course, as well as sine tables and trigonometric calculations is also very important to consider, right? So Aryabhatta gave a very systematic way, right? And it almost looks like, we often say Newton, right, was a genius because he looked at calculus, he looked at mechanics, and he looked at gravity, right? And they were all connected, because when you talk about infinitesimal change in position, let's say, in mechanics, you have to connect it to the differential, the concept of the differential, right? Similarly, Aryabhatta also looked at the intricate connections of the mathematics he developed, as well as the planetary motion, that talk of planetary motion that he had looked at, essentially, right? So I mean, his geocentric model, though, right, was later on looked at from a more heliocentric aspect. But the idea of relative motion and periodicity, right, is something that was very, very important in that way. Now, let us move forward to Brahmagupta, right, who gave the treatise Brahmasfuta Siddhanta, right. In that, he talks about fundamental concepts of zero, as well as the concept of negative numbers, right, which were very revolutionary when we talk about mathematical operations, so to say, right. And so when we talk about Newtonian mechanics, right, and when we talk about relativistic physics also, the way in which we define singularities, we define constructs of negative numbers as well. Like for instance, in Minkowski space, the metric, we talk about the metric, it is often with a minus sign that the time aspect is given with respect to the spatial aspect, so to say, right, minus ct x, y, z, right. So the negative numbers aspect of things is very important to define anything on the front of mechanics, on the front of orbits, or any astronomical calculations as well. Now, in the case of Brahmagupta, it didn't quite translate directly. I mean, he didn't work on many aspects of planetary motion per se, but his work was important in derivative works, in further work, so to say, right. Now, Bhaskara too, right, in the Siddhanta Shiromani, right, he spoke about Tatkalika Gati. Tatkalika Gati means instantaneous motion, basically. And when we talk about Tatkalika Gati, we have to basically talk about the concept of derivative in a way, right, because you're talking about the instantaneous motion, not a motion over a certain period of time. So we see there is a certain understanding of how the motion is tracked and determined for a certain instant in time, right. He obviously had a use of various small increments of the algebraic and the trigonometric side also, so to say, and which was very important in the Kerala school. We often talk about the Kerala school of mathematics, right. This was very, very important in that respect, right. Now, Bhaskara too also had a very important role to play in the Kutaka method. Kutaka method basically was to solve, it was a method based on fractions to solve indeterminate equations of the form ax plus by is equal to c. Okay, and they are basically called the Diophantine equations. These are called Diophantine equations, and it was used for this kind of an equation, so to say, right. Now, this was very important because when you do recursive planetary calculations, right, when you are doing basically things like even eclipse corrections, there are many such techniques, right, which can be applicable or which are applicable in various ways, which has a premise on these numerical methods or these methods of algebra which were developed back in the day as well, right. So, but you may ask whether it directly translated to the works of the Western philosophers and mathematicians or astronomers. I mean, there are debates on that, right, because there was a lot of civilizational flux that was happening, right. We also, many people say that our algebraic aspect or mathematical aspects went to the Middle East, right. Today we call it algebra from al-jabr, right. But the motivations of that, right, the origin points of that is a whole different debate altogether, right. And how that further led to influences into the Hellenistic or post-Hellenistic world in the European traditions is again a matter of debate, right. But I like to believe that because we have had a long history of very precise applications of mathematical concepts, right. We were discussing about the Sulba Sutra, right, where how the altars were prepared and the geometry of that. It shows a very advanced method or understanding of the geometries of altars and how the applications of tiling or tessellation, as it is called, right. There is a beautiful constructions which are having very different kinds of geometric units that come together beautifully, right. So tessellation is a part that comes into the picture. So definitely there was a lot of advancement on that front, right. Now, when we talk about the intricate link between the two, right, and that is what I would like to highlight here. It was not from Newtonian or post-Newtonian, but I would say pre-Newtonian physics, right, from the Bharatiya Gyan Parampara, where we see this simultaneous development of the mathematics and the astronomy, so to say, right, and the application that was synchronized, right. It was going hand to hand, it was going together, right. And till we appreciate that, we cannot understand the enormity of this, right. And that's why I started with this whole contextualization that Einstein's relativity would have been nowhere if differential geometry was not advanced as it was, right. Because everything from the Ricci tensor to the curvature aspect, right, to how we define the stress tensors and the transformations thereof, right, covariance, contravariance, so on and so forth, right, translation in certain manifolds. These are all things that came from differential geometry that translated into Einstein's relativity, general relativity. So similarly, because of Aryabhatta's work, because of Brahmagupta's work, because of Bhaskara II's work, and their synchronized corrections in astronomy, their applications, we would not have reached where we were, right? And be it prakarana, be it the other declination based aspects, be it frame dependent aspects, these are all things that show us that we did have a lot of understanding of the contextual mathematical advancements and their specific applications in the astronomical tradition, so to say. So that is what I think is a beautiful thing to, celebrate.
And talking about mathematics, I heard somewhere, I mean, there are proof also, right? Both the Greek mathematicians, some of them, and also Pythagoras, they write texts, right? About their findings. And they somewhere mention that it's not through Middle East or Al-Zubair, I think the name. So that's the derived from algebra derived from that name. But the original knowledge came from India.
Right. I mean, and here it is very important to understand that there is a theory which is often spoken of, which is the Aryan invasion theory, right? But there's also a very prominent theory, which is that people went from here outwards, right? There's obviously a lot of debate on which is it, right? Out of India theory. So, I mean, however, given that there was a certain corpus or a certain central crux or a core of wisdom or knowledge which was there, I mean, even in nature we see there's something known as osmosis, right? So I like to think of it as civilizational osmosis, okay? If you have a concentration of wisdom or understanding, sophistication of concepts, it is only natural that it will spread outwards, right? Now, whether there was a counter spreading or not is a different question. But there was definitely a spread from the Indian context, because if you look at the advancements at various points in time and you go back quite a bit essentially and see, there is something known as etched in stone. In English we say etched in stone. That's why I say temple architectures and the artifacts that we see, right? That reflects an advanced understanding of construction on the side of architecture itself, on mathematics of that architecture, on the metaphysics of the mathematics of the architecture, right? And you can go on and on about that. So clearly, if there was such a level of advancement there, right, then it definitely has to osmotically, right, move outwards and have an influence on various other traditions as well. So, I mean, if I were to give a, one buzzword, so to say, to coin here for this thing, I would say it's civilizational osmosis.
Very nice, civilizational osmosis. And like playing by their rules, we also getting tracked of that. Like empirically, we are getting much more discoveries.
Absolutely. And we unfortunately don't appreciate that. And that is also part of the colonial aspect, that is part of the politics of intellectualism or wisdom, knowledge creation and promotion, so to say, that we selectively don't go for those things that are from Bharat itself. And it's still going on today, right? Even today I see many of the textbooks, slowly things are changing, right? But we do not appreciate, I mean, very simple, Bodhayan theory, right? It should be known as Bodhayan theory, right? I mean, not a Pythagorean theory, right? And the ideas of pi, right? And the advancements of pi, so to say, right? Just now, recently, the 14th of March is regarded as World Pi Day, right? And I shared about this very fact that, Madhava, gave a 11 precision up to the 11th place of decimal, and back in that time is a remarkable thing in itself, right? And we should be appreciating that and how it led to different aspects of the astronomical side as well, right? So that is something very, very important. Yeah.
Talking about special relativity, the unification of space and time in Einstein's relativity introduced the idea of four-dimensional space-time curvature as the foundation of gravity. So the general theory of relativity, we are talking about the general theory of relativity. Indian philosophical traditions such as Advaita Vedanta's Brahma Satyam Jagat Mithya, the world is an apparent reality, offer an alternative view of space and time as illusions of perception. Can such non-dualistic model provide fresh insights into the geometric structure of space-time?
So when the Einsteinian revolution happened, basically the idea which came to the fore was a fundamental exploration of space-time itself. Space-time was earlier regarded as a parameter. Right? It was regarded as something which is absolute, and it is something with respect to which you take differentiation, right? You take the time differential of something and you know the temporal evolution, for instance. Now, as soon as Einstein's aspect of general relativity came into the picture, it was, number one, no longer an absolute parameter, right? It was not an absolute parameter, it was something which was contextual, it was frame dependent. And now when we are talking about quantum gravity, right, and we have come to the stage of quantum gravity, we are not even talking about it as a parameter anymore. We're talking about it as an emergent property, it an emergent kind of emergent entity, right, emergent entity which is building all that we see around us. It is not something fundamental itself, right? So not only is it not absolute, it's not fundamental either, beyond a point, right? Now you used the very well known kind of shlok aphorism, right, which is Brahma Satyam Jagan Mithya, right? Now this is very, very interesting and important to think about, right? Because in Advaita Vedanta, this idea of mithya, what is mithya? Now people often say that mithya is equated to myth, right? There is this concept which I'm sure you have seen in one of the books. I don't want to kind of delve into that beyond a point. Myth, right? Myth and mithya, right? Mithya is not quite myth, right? Mithya is an emergent, yes, illusory aspect, right? But it has its own importance of its own in a sense, right? Because when we talk about Maya, right? Maya is that which veils the reality which is underneath. Maya itself has a very important role to play within Vedanta, right? And Maya itself is spoken of as timeless, without an origin, right? Back in the time, and it has been there always, and it does what it does, right? And therefore, when we talk about, it's not a fatalistic kind of thinking, but in Hindu thought, we say Mahamaya ki jai, right? Mahamaya ki jai means there is a certain intricate way in which Maya is doing what it is doing, right? And there is an ordering of sorts.
And acceptance
of sorts, right? And where the individual agency is no longer so sacrosanct or important that it can supersede that which is beyond it, essentially, right? So Mahamaya ki jai is a very interesting way to highlight that. So in Advaita Vedanta, I was talking about Paramarthika and Vyavaharika Satya, right? And this idea of what is contingent and what is emergent, essentially, right? In Buddhism, we speak about shunyata. Right? Shunyata basically means that there is nothing which is sacrosanct in itself, right? There is nothing which is in and of itself, right? It is all dependent on things that are presupposing it, or is creating a contingency, as it is called. It is something which is creating the correlations, right? And in fact, they go so far as to say that relationship sans relata. What does that mean? Relations are more important than that which it is relating. Right? It's a very beautiful thought, right? So the correlative aspect is more primary than the reductionist approach where you have some building blocks, so to say, right? Now in modern physics, this question of Brahma Satya, right, and Jagan Mithya is also important, because we talk about projections, right? This word is often used, the projections of Brahman through Maya, right? And that's what we see around us. Now in modern physics, there is a theory called ADS-CFT, right? ADS-CFT, which is a theory which is associated with string theory, so to say. It's kind of part of the bigger superstring kind of framework, so to say. And in that we say that gravity or bulk dynamics or the space-time is constructed from, or projected rather, from correlations of elements on the boundary of that bulk. So if you are looking at, you can think of it like a bowl, right? Like a bowl, right? The bowl has a certain shape. The elements that are within the bowl, right, are kind of like in space-time, the objects that are in space-time. So it's called the bulk, as it is called, right? Now if we think of the perimeter of that bowl, right, and we define something which is called a field theory, a conformal field theory, there is a certain mathematical or a physical theory, and the elements of the perimeter, the way they are connected to each other, the way they are correlated with each other, that correlation, if it can project the space-time, the workings of gravity in the space-time, that is what ADS-CFT is talking about, right? How the perimeter is projecting the bulk, the correlations or dynamics of the perimeter. So it is very similar in some ways to this idea that there is a more fundamental reality which is being projected, almost like a hologram, holographic principle, right? And what you are seeing is actually just a projection of a other kind of space which it is kind of a projection of, essentially, right? So this idea of ADS-CFT is very, very important in that way. And Indian traditions give a very sophisticated aspect of time which is also cyclical, right? Because we talk about Roger Penrose's cyclic cosmology model, but we have seen in the last few discussions also how there is a cyclicity in our own Indian traditions, right? The Kalpa, for instance, the Chatur Yuga, right? And the many sets of Chatur Yuga, right? In fact, the Pralaya, there are 4 different kinds of Pralaya, right? It's not just one, and that's a common misconception, right? There is only Pralaya and that's about it, but Pralaya has 4 different kinds. Daily Pralaya, there is a Pralaya after 1000 Chatur Yugas, right? Then there is the final kind of dissolution into Brahman and so on and so forth, right? So even within Trikashaiva Darshan, when we talk about pulsation, spanda, right? We talk about time as an emergent property of Paramashiva, which I have mentioned about previously. In the Jain epistemology also, we come across Dravya Kala and Vyavarika Kala, right? So Dravya Kala is ontological time and Vyavarika Kala is empirical time. Right? So there is something more absolute and then something which is more immanent, right? So again, these diverse frameworks talk about something which is relational and contextual again, right? So while they do not talk about structure of space-time per se beyond a point, they definitely talk about a contextual relational framework from which space-time is coming forth, right? And is contingent upon, right? It may not speak about quantum gravity's loop quantum gravity, for instance. It's not loops, or it's not some cellular kind of structures in some form, right? But it is saying that there is an underlying correlative aspect which is giving rise to the space and time, and that space and time itself is relational, cyclical, and giving rise to a lot of different things we are seeing upon it, but it is not absolute in itself. Right, which is what relativistic side is also mentioning about. Yeah.
So talking about space and time, gravity, curvature of space, I like to talk about black holes. Right. So that's massive celestial body.
Yes.
So black hole challenges our understanding of space-time by creating extreme gravitational wrapping, potentially linking different parts of the universe. Do ancient Indian cosmological ideas such as Mahakalpa cycle, Vishnu's Ananta Shesha, cosmic serpent that is, and the multi-layered lokas in Hinduism, Buddhism and Jainism in their traditions offer conceptual parallels to modern theories of singularity?
So black holes, right? Black holes is, black holes are something which fascinate, one and all. In fact, I remember back at Cambridge, right? I mean, when I was a teaching assistant during my doctoral days, one of the students came up to me and said that, I am most interested in the very fascinating sides of physics, right? And why are we doing these very dreary experiments, so to say, right? I mean, it was a very interesting, very sweet question from somebody who was attracted to physics initially, and still is, I'm sure, hopefully. But one of the things that fascinates everyone, intrigues everyone, is black holes, right? So black holes basically are the most extreme case of the warping or the curvature of space-time, right? So when there is something which has such high density that you can almost think of it like perforating, like piercing through the space-time fabric itself, and so much curvature being there that nothing, not even light, can escape from it. That is what we talk about as black holes, right? Now, whether black holes was discussed, right, in the sense of physics of it or the metaphysics of it in the Indian traditions is a question that is not quite, I would say, framed or to be conceptualized in that way. I would rather address the problem of singularities, right? Singularities have been looked at both from an immanent empirical sense, from a metaphysical sense, right? And from a very, very ontological kind of perspective also, from the very foundations, so to say, right? Now, you gave some terms, which is the Mahakalpa. You spoke about the Ananta Shesha. There are various other Puranic tales as well which talk about it. So, when we talk about the Mahakalpa, right, there is this aspect of cosmic creation and dissolution, right? And how does that happen, right? So, we say that in scientific aspects, there is this concept of the big bounce, okay, big bounce. What is a big bounce? The big bounce is basically when you have the Big Bang, right? The Big Bang gave rise to everything we see. It expanded, it persisted, and then the theory is, it again ties back to the cyclic cosmology model. everything will again go back into a singularity, right? The big crunch, so to say, big crunch, right? Now, gravitational collapse and how it happens is a matter of debate still. It's not something we in physics have kind of spoken about, as the conventional way of thinking about it, because at the moment the universe has been seen to be just expanding. It's accelerated expansion that we talk about, and what will happen afterwards is purely speculative, right? It's not something we can establish even, for that matter, right? So Mahakalpa and how this transition happens is a question where the mediation of a potential singularity, right? Because if something has come out of nothing, or at least appearance of something which is very localized, logically speaking, it should again go back to a certain point of singularity, right, and so on and so forth, right? That is a very logical construction, right? But whether that is a physical or the scientific construction is speculative still, right? Now, in the Ananta Shesha, when we talk about this aspect of the Ananta Shesha, it's a very interesting way in which it is the motive or the representation is shown, right? So there is a cyclic recurrence, the way the coil of Ananta Shesha is oriented, right? And so how some people have proposed that it looks like a event horizon of this black hole which is present, and in fact in the Milky Way we do have at the very center of the Milky Way there is a black hole, right? That's what is been discussed in scientific circles, and that is giving rise to a lot of things, right? Now, a question is, if a black hole is consuming everything, how is it being creative? How is it creating something, right? Now, one simple resolution of that is obviously given because of Stephen Hawking's work. So he spoke about Hawking radiation. So when things are taken in by the black hole and there is a randomization of state, right, the randomization of all that we see around in terms of the states of the system, there is also an outpouring or an emanation, radiation of a certain kind, which is randomized again, but there are certain things that come out of it. Now, there is also a theory that a black hole is actually bridged, it creates a bridge, right, which is a wormhole. There's a concept of a wormhole which goes out into a white hole, right, and there's a bridge. There are even advanced theories which say that quantum entanglement, which we spoke about, quantum entanglement actually creates certain kinds of Einstein-Rosen bridges, right, which are basically these bridges that I was talking about. But again, these are purely speculative because we do not have a way to kind of firstly explore a black hole, right, and which is unfortunately why Stephen Hawking didn't get a Nobel Prize as much as he should have potentially. And again, on the quantum side, we cannot see whether the entangled particles are actually creating a black hole ER bridge, an Einstein-Rosen bridge or not, right? Now, there is also a very interesting story from the Bhagavad Puran, right, when Hiranyaksha, right, he actually took the earth, the whole kind of earth, and then in the Garbhodaka ocean, he kind of took it very deep inside, and then he tried to kind of pull it back inside into the ocean itself, right? And Vishnuji, Srihari Vishnu, he came ahead with the Varaha avatar, right? Which is why we often see that he, with his tusks of the Varaha avatar, is lifting the earth, right? So again, that kind of is a certain imagery of how the singularity, right, a certain kind of aspect of pulling it down and the regeneration from it, right, or the saving of it from that singularity has been spoken about, right? And so, well, you could say that it is a very high curvature space-time, but I wouldn't go that far because it's clearly a metaphorical, potentially metaphorical resonant aspect, but it's not quite physically in that same way, something you should be discussing. We should be.
It is hard to imagine.
Yeah, it's hard to imagine, and I don't think they were discussing it at that level beyond a point, right? Because it was more of, because when you are doing poetry, when you have a poetic understanding, it encompasses a number of different dimensions, right? Spiritual, immanent, and conceptual, and so on and so forth, right? So that kind of has to be looked at. So when you talk about Devi Bhagavad Puran, this idea of Pralaya actually takes everything that we see back into the avyakta, that which is not expressed, that which is undifferentiated, right? And we see that in quantum field theory as well, right? When we speak about this dissolution of all the excitations back into the fundamental fields, right? Now, one can say that in terms of the immanent particulate nature right? It is removing that particulate nature and taking it back to its fundamental aspect, right? Now, this, whether this can be spoken of as a conceptual singularity, right, or a statistical singularity even, or a singularity of degrees of freedom, right, is not quite right, because even the field itself has a degree of freedom. It has a latent degree of freedom, right? But in Advaita Vedanta, when we talk about Brahman, that is definitely a singularity of sorts, because there we are not talking about any degree of freedom. We are saying that it cannot even be articulated, it cannot be even rationalized or related in terms of any articulation for that matter, right? So definitely when we talk about Advaita Vedanta, right, that is a field, so to say. I won't even call it a field, right, because it's something beyond description, right? And that is a very beautiful way of thinking about it. It's the ontological black hole, right? It's a black hole. Yeah, it's an ontological black hole, right? Because it's a black hole which is beyond all expansions, degrees of freedom, descriptions, articulations, right? So one can talk about it in that way. In Jain philosophy, again, this aspect of anekantavad, right? How this relates to what is the reality as such, right? Even in the aspect of Buddhism, when we talk about this idea of shunyata. So when you say pratitya samutpada and dependent origination, the question is, what is real then? Right? So that question itself, according to them, is a moot question. It's not something that can be answered, right? In fact, one thing which people often say is that I like to see Buddhism as not a negation of Vedanta or Hinduism per se. Buddhism is talking at a certain realm where it is not quite addressing the realm beyond the level of negating. And this level of negating has been done in the Hindu parampara as well. It has been done by neti neti, right? When you talk about that which it is not. But what is beyond is something which Buddha never quite addressed, right? But that does not mean it may not be there, right? So when there is a famous story which is that one day one bhakta, he came to Buddha and said, is there no God, right? Buddha smiled. In the evening, somebody says, is there a God? And Buddha still smiled. He did not answer either of them. He neither posited it nor did he negate it. So does that mean that there is no position that you can take? Does that mean that there is no negation that you can take? That question itself was never addressed, right? So when you say shunyata, I like to think of it as that empirical singularity, again the ontological singularity, but whether there is something at a different realm, different level of existence and understanding is a question that I don't think Buddhism addresses, right? And I think Vedanta addresses in a slightly different way, but the way to get there with neti neti still is looking at a singularity. It is nothing, none of the things that you see around you, not this, not this, not this, not this, infinite regress, none of them, right? Which means there is a singularity of what it is, right? And that is where the tricky part comes in, essentially, right? So how do you kind of even discuss about that, right? So in the Lingodbhava episode of the Linga Puran, there is a very interesting story, right, which is that of the Jyotirlinga. Okay, and there was a discussion when there was this aspect of there was a discussion going on between Sri Hari Vishnu and Brahmadev, right, about I think the primacy of who is more prominent and more kind of has more agency and things on that front. And usually when such discussions happen, as we know, the resolution is found in Shivji, right? So they ended up going to Shivji, and then Shivji said, okay, well, what I will do is I will expand in this Jyotirlinga, right, which is so high and so low as well in terms of the expansion aspect of it, that and he asked them to find the end of it, and he said that tell me, I mean, where is my end, where is the end of my expansion? And of course they couldn't find that, right? So in the case of determinacy of expansion, right, spatial and temporal and so on and so forth, that was a very beautiful way in which Shivji showed that he is that singularity. He is a singularity of conceptualization. You cannot conceptualize it within the spatial and temporal aspects as such, right? In the Mahabharata, when we talk about the Srimad Bhagavad Gita and Sri Krishna's Vishwarupa, right? Even in that, they have this way in which he gives this Sri Krishna gives this overwhelming form of infinite universes in him, right? And so Arjuna sees that the dissolution happens and everything comes from thereof, right? So while Indian knowledge systems may not have given the exact definition of black holes in the sense we know it in physics, but the concept of singularities at the level of ontology, epistemology was definitely there, right? In many different Puranic traditions, in the Itihasa, in the case of Advaita Vedanta and Prakasha Darshan as well. So that is very, very important. Yeah.
So talking about the massive celestial bodies, light and the bending of light. Light from distant galaxies experience redshift due to the expansion of the universe, a key observation supporting the Big Bang model. Indian cosmology describes the cyclic creation and dissolution of the universe through Srishti and Pralaya. Can this perspective provide alternative insight into the nature of cosmic expansion and the ultimate fate of the universe?
So the way in which the redshift that you are talking about is one of the many ways in which we see that the universe is expanding in the way it is. So back in 1927, Georges Lemaitre's kind of gave this whole hypothesis of the Big Bang, and thereafter Hubble and observations of Hubble's gave us this understanding that there is an accelerated movement, expansion of sorts. Now, there is a hypothetical kind of extrapolation, if you will, right? Because it's not something which is logically conclusive, right? You could always have phases of a universe where there could be expansion and contraction, so to say. I mean, one could potentially posit that. But then we also see that in cosmic background radiation, we see certain signatures from the very early universe. And more or less now Big Bang is taken to be a fairly kind of well-accepted theory of sorts, right? I mean, so the idea is that, again, from a singularity, this aspect of singularity, there was something that kind of came out. And this, before moving forward, this idea of singularity that we were talking about has a very important role to play in the whole conception of gravity. In fact, the reason gravity is not reconciled with the other forces is because of certain specific singularities, essentially, which is not there in the case of the other forces. And even when we talk about string theory, the reason we talk about renormalization, basically, which is that there are many higher order corrections to different phenomena, higher order kind of phenomena to some fundamental phenomena, that can only be stopped with certain kinds of renormalization techniques. These are mathematical techniques. And even in that, the singularities are what we are trying to avoid, right? So coming back to the Big Bang, when we say that we have the Hindu thought, right? You mentioned about Srishti and Pralaya. In Hindu thought, we also have Sthiti, right? Srishti, Sthiti, Pralaya, right? Which is basically creation, preservation, and destruction. And these cycles are often associated with certain time scales, right? So the Kalpa, for instance, 4.32 billion years, and the Mahakalpa, which is often spoken about, gives the idea that there is a periodically kind of regenerating universe, right? So that again ties back into this idea of the cyclic cosmology model. And the Big Bang itself has been part of the big crunch, big bounce kind of aspect of things, right? So, in the Bhagavad Puran, the Vishnu Puran, right, you see that, the universe's end is not the ultimate end, right? It is something which is giving rise to a new cosmic cycle, right? And this new cosmic cycle is spoken of in terms of the breadth of Sri Hari Vishnu. Right? This is the way poetically it has been kind of spoken about. It's a poetic yet profound analogy, right, of this cyclic cosmological
as depicted in the Virat Roop.
Right, the Virat Roop as well. And the vitality aspect is given by the breadth of Sri Hari Vishnu, right? So which is a very interesting aspect of things. Now, when we say the idea of heat depth, right, that is one thing which we have been discussing throughout. And so we need to understand that the heat depth, the nature of the heat death is spoken of in many very specific parameters, right? Entropic parameters, the aspect of internal energies and energies in general, right? Now, the question is whether that is exactly how we talk about it in the case of Pralaya. Is not always the case, right? There are points of similarities and very, very important points of divergence as well, right? The way the degrees of freedom kind of cease to, diversify or go into different more entropic states, and how it is described in the Indian knowledge systems there are certain divergences thereof, right?
One thing is certain, like zero vibration.
Yes, it is kind of stilling down because it has reached, you can think of it as a saturation point, right, of how much more microstates or how much more entropy it could potentially have, right? So that is the heat death kind of aspect. Now, when we speak about the universe and the fate of the universe, one very important thing to understand is whether the universe is the only universe or is it part of multiple universes, right? This whole idea of multiverse, right? Now, though everywhere we hear about this word verse, right? In the metaverse, this verse,
and we will talk about that in
one of the episodes, yes. And so multiverse, I mean, the idea of loka, right? Many types of lok, right? I mean, this has been found within the Bharatiya Gyan Parampara as well. So, for instance, when you talk about the Bhagavad Puran, right, and the Brahma Vaivarta Puran, there's this very interesting kind of anecdote where Brahmadev comes to Krishna, Shri Krishna, right, and he's visiting Shri Krishna in Dwarka, right, and he introduces himself as I am Brahma, the creator of the universe, okay, and Shri Krishna, as you know, he's very kind of, he does things very non-linearly, he does things even very mischievously sometimes. What he does in this context is he goes and finds and calls rather all the other Brahmas, that many universes, right? And there are a number of different Brahmas who enter the chamber of Dwarka's royal chamber as such, right? The court of Dwarka, right? And Brahmadev is basically humbled. He gets humbled. He says that I am not the only Brahma, right? And there are many Brahmas around, right? And I also have a limited kind of time of sorts, right? So this basically shows that there is a hierarchical aspect, there is a multifaceted aspect, and how everything is encapsulated within a larger context, right? So the larger context is what Sri Krishna, or when we talk about Advaita Vedanta, that is what it is placed within, right? And so Hindu cosmogony, I mean, and cosmology for that matter, talks again about the relational aspect, right? The universe not being absolute itself, right? And how the universe's transition and the conceptual movements, or even the actual movements, are part of a larger cyclicity, right? That thing is very important to understand when we speak about the Indian knowledge systems, and we talk about the ultimate fate of the universe as such.
Yeah, that's very nice, sir. Thank you very much. So we can now think of light and gravity in different light.
Absolutely.
After that session.
Right.
So we will end our session now. Thank you.